Hi guys. So today we're going to be looking at non-ideal op amps. Op amps are really good at amplifying voltage in a circuit. And we'll look at this circuit right here and explain what it does at the end of this video. So in an op amp, typically we have two DC voltage sources connected to it, VCC and VEE. This is positive. This will be negative or ground. In the positive terminal of an op amp, we have a non-inverting input. The negative terminal will be the inverting input. And that's just basically what it is for looking at just this op amp on its own. Now, if we were to draw the inside of what this device is, it would look something like this, where you have an input resistance, you have an output resistance, you have a dependent voltage source, which has a gain. This is the gain of the op amp, which depends on the voltage in. Voltage in is just the voltage drop across the input resistance. You have the output voltage. And here we could ground it just to make it simpler. And this would be the non-inverting input, which is the positive terminal. From here to here will be the inverting input. Okay, so this is the insides of the op amp. Now, we're going to try to connect it in a way that characterizes this whole circuit. So this is just the op amp itself, and we'll look at the whole circuit in a sec. So let's redraw the insides of the op amp again. So if we were to redraw it, we have the input resistance, output resistance, then we have the ground, like that. And the non-inverting input is actually connected to a voltage source. So this is plus or minus Vs, which is connected to the ground. And this part, the inverting input, is actually connected to V out, which is over here. So what we can do is we could say this connects all the way to here. Okay, so this is the circuit. Just the insides connected to the independent voltage source, and which is the non-inverting inputs connected to the output voltage. So we have, if we apply nodal analysis here, we could say this is Vs, and this node right here is V0 because it's connected to here. So if we look at one of the nodes here, let's look at, let's see, so we have current going in here and current going in. So yeah, let's look at this node, the V0 node. Let's look at that. So we have current that's going this way and current going this way. So we have two currents going into the V0. So if we apply KCL, using nodal analysis, we could say, okay, well, the current going this way is just Vs minus V naught divided by Ri, plus the current going across R naught is just, remember this is A naught V in. We could say, okay, well, this is grounded, so this node right here is A naught V in, is A naught V in minus V naught divided by R naught equals 0. Now, V in is actually just Vs minus V naught. So if we simplify this equation right here, we could say Vs minus V naught over Ri plus A naught Vs minus V naught divided by R naught equals 0. Okay, so now we have an equation with Vs and V naught. We'll assume that Ri and R naught is given, same with A naught. So we want to simplify and try to find the overall gain of the circuit. So the gain of the op amp is A naught. The overall gain will be A. A is just V naught over Vs. So it's the output over the input. So we want to find A, which is V naught over Vs. So we have an equation where we could simplify in order to get the overall gain. So let's simplify this. So we'll say Vs is equal to 1 over Ri plus A naught A naught over R naught, right? Minus V naught of 1 over Ri plus A naught plus 1 over R naught. This equals to 0. So let's simplify it further. We have Vs over R naught plus Ri A naught over Ri R naught. Bring this over to the other side, so equals 0. We have V naught. We have R naught plus Ri A naught plus Ri divided by Ri R naught. So these two denominators are the same, so we could actually cancel them out. So we end up with Vs R naught plus Ri A naught equals V naught, which is R naught plus Ri A naught plus Ri. Okay, so now we have Vs and V naught isolated. We could actually divide this by Vs and bring this whole term over to this side in order to get the gain. So the gain will be V naught over Vs is actually equal to R naught plus Ri A naught divided by R naught plus Ri A naught plus Ri. Okay, so we found the gain. We simplified for the gain of the overall circuit. Let's try to simplify this a little bit further, just to see what is going on in the circuit in a simplified manner. So if we divide the bottom term by R naught plus Ri A naught, we're able to get 1 over top, so we'll do that. So we'll say 1 divided by R naught plus Ri A naught plus Ri divided by R naught plus Ri A naught. We could simplify this even further. We could say this is equal to 1 divided by, since these two terms are the same, and this term isn't, so we could say 1 plus Ri divided by R naught plus Ri A naught. Okay, so this is the overall gain of this circuit here. So this will define what is going on in terms of V naught, the output, and the input Vs. So let's just let's assume, for example, Ri goes to infinity, and R naught equals 0. So we could say Ri is significantly greater than R naught. So let's see what happens with the gain. So the gain becomes 1 over 1 plus Ri. We'll say it's a huge number divided by R naught is 0, so we'll leave that. Ri, A naught. Well, our i's can cancel out, and we get 1 over 1 plus 1 over A naught. Okay, so we got rid of the terms, the resistances. If Ri is significantly greater than R naught, we could say that these two resistances don't really affect the gain of the circuit, the overall gain of the circuit. Now let's assume the overall gain, the op amp gain, A naught, we'll say that goes to infinity. So if that goes to infinity, we end up with 1 plus 1 over infinity. This actually goes to 0, so we actually end up with 1 over 1 equals 1. So we end up with V naught over Vs equals 1, if we assume these conditions, 1, 2, and 3. And we could say, okay, well, if V naught divided by Vs equals 1, that means V naught equals Vs. And this is exactly what this circuit does. This op amp circuit right here, is actually called a unity gain buffer. So the unity just means 1. And if we look at the gain, since the gain is 1, which is here, V naught equals Vs. So the output equals the input. So if we assume these conditions, that's what this circuit intends to do. It intends to have a gain of 1. These conditions, 1, 2, and 3, where Ri is going to infinity, R naught equals 0, where Ri is significantly greater than R naught, and A naught, which is the gain of the op amp, goes to infinity. These are conditions that will reflect an ideal op amp circuit. We'll look more into that in the next problem. This is just a non-ideal op amp circuit where we actually have to look at the insides of the op amp. For an ideal op amp circuit, we'll actually don't have to look at this at all. We'll get into more detail later, but if Ri is goes to infinity, this just becomes a short circuit. And if R naught equals 0, that means that this right here is an open circuit. So the Ri and R naught, the input resistance and output resistance, won't affect the overall gain of the circuit. Awesome, thank you.